So I'm trying to show you my screen. Okay, so just type RStudio. And the moment you start typing the RStudio, it will pop up the RStudio. Now, that is not R. If you try to type R, the studio may come, but that is not what you're looking for. So I just type an R, okay, and my screen is trying to show me the entire arena. Which is not what I'm looking for. Okay, this is not what I'm looking for. So you should look for the RStudio and open it, just like I have opened mine. Don't look at whatever I've done, because it won't help you. So what I'm going to do now is, I want to believe that most of you have installed your RStudio. And once I believe that most of you have installed, I'm going to go through some processes that will help you. Okay. So I'm going to create, most of you will have something like this, which is showing a new R script, with what I'm seeing down here. What I'm seeing down here. Okay, so you have your cursor blinking at number 1. Please lower your hands. Please lower your hands. We are done with those raising their hand. Okay. Please lower your hands now. Lower. Because I think that your hand raising has overtaken my screen. Lower your hands for me so that I can.
Sir, please, can you repeat that?
I said is you lower your hands.
Oh, okay.
Lower your hands for me. All right, so you have your RStudio with the cursor blinking at number 1. Do you have that? Type yes if you have that. With the cursor blinking at number 1. See whether you have your eyes with a cursor blinking at number 1. Just type yes if you have that. Normally, I will expect about 10% to be able to do that, then I can move on. Perfect. So majority of you are having that. Excellent. So, what I want to do is, I want to show you something about my screen. Ladies and gentlemen, I just hope that you all see my screen. Okay. I just hope that you all see my screen. So what I want you to do is to type library car. Library car. Library into bracket car. And then run it. If you want to do running, click on the run on the top right. Library car. Now, if you do not have that package installed, it's not going to show. So you must have the package installed. As you can see, I have my package installed. And so when you run it, at the bottom of the console, where your results are shown on the left, is known as the console. The console. Your results will be showing in the console down there. I'm taking my real time to really take you through this. Okay. Then you type MT cars, something that I told you the other time to already do. I'm only repeating it for the purpose of this course. Now, if you have not installed the library car, just go on the bottom right, on the space on the right, you see packages. I'm hovering my cursor on my packages. Click on packages and click install. Please, you see my screen? If you see my screen, I just need 10 people to type screen. I just need 10 people to type screen. All right. Thank you. So you see my screen. So you should search for, you should go to packages and click inside the packages car, like CAR. CAR. Now the guy who asked the question that he doesn't know how to install R. One gentleman said, how do you install R? Is a reason why, I don't know, I think it's a Lydia Abuachochin. Lydia, I hope you are following me. So that's how you install car. Into the search, then you select car and click install at the bottom. And then you give it some time, car will install beautifully. Car will install. I have already installed, so I need to click cancel. So once you do that, type empty cars and run it. You can run or click Control Enter. Control Enter will run, and you will see your data showing like this. So what I'm going to do is, yes.
Yeah, unfortunately, I cannot find the library path. He said I should.
But I told you yesterday, I told you on Monday to do this already.
I have installed my R Studio already. But
I told you that you are supposed to install R before your R Studio. Do you remember?
Yes, I did, sir.
Okay. And you said you cannot see where the R Studio is on your computer.
Please, no, please, where the cars are. You know, you mentioned right now, a while ago, that you go to
I said you should go to packages. I said you should go to package. And I asked you, do you see my screen? And you said yes. And I hovered my cursor on packages for you. You must have internet to be doing this.
Yes, I do.
No, listen, you are not listening to me. I'm saying that I hovered my cursor on packages, yes, and I asked you whether you see packages. And you said yes, right?
Yes, please.
So if you said yes, then you should click install and go and install car.
When you click install, what comes to my screen is repository change.
And I said in that repository you type car. That's what I said. I said this thing yesterday, and I've said it again.
Yes, sir. All right, sir. Thank you.
Okay. So once you've installed the car, you type library number 1, and then you type empty cars number 2, and you should see the data empty cars down there in your console. Now, I want you to please raise your hand if you can see the empty cars data down in your console. If you can see it down in your console. Now, ladies and gentlemen, you have to note that it's not everybody who will be able to finish everything before we continue, because some people don't even have a laptop. The laptop doesn't have batteries. So it is not possible that everybody will have to do this before we continue. So I'll always be using a criteria of 20 people being able to do, and now I've even gotten over 40 people, over 30 people who have done it. All right, so please lower your hands. Those of you who have been able to do that, lower your hands nicely for me. And please get used to raising your hands and lowering your hands. Get used to that a lot, because we'll be doing that a lot to be moving on. If you can't raise your hand or lower your hands, you can type search. You can type yes and things like that. Eric, is your hand up for a question?
No, mine is not up.
Eric, your microphone is on. Please turn off your microphone. It helps me to know that you don't have a question. Otherwise, I might be ignoring you with any hand raise. So if I keep calling you and you still don't have a question, What it means is that you have to lower your hand because it deceives me into thinking that you have a question. Okay, so now that you have your MPG data showing, okay, we are going to summarize the data. We are going to summarize the data. In case you've forgotten, last time when we met, I explained everything about this data. I said the data is made up of certain cars made up in 1974, 5, 73, and 75. And the data shows the MPG, the miles per gallon. And that is dependent on the cylinder, the displacement, horsepower, drags, the weight, which is WT, the kilometer, the vertical speed, which is a dummy variable, 0 or 1, the automatic or manual, which is a dummy variable, is binary, and then the gearbox, which is also a dummy variable, is not binary, okay, it's multinomial in character, and it has a range of between a 3 gearbox, 4 gearbox, 5 gearbox, and so forth. And then finally the carburetor, which is also a categorical variable. So this was the data, but the data is quite a lot, so I want to summarize the data. And to do that, type summary into the command window. Type summary into bracket empty cars, and then control and enter or click run, and you should see the summary of the data there. You should see the summary of your data right there. I will not ask you yet, those who see it, but I'm going to ask some questions because that will pull out. You can type your answer in the chat. Who can tell me the median for, I'm just going to hide mine because I want you to use yours. What is the median for MPG? What is the median for your MPG?
20.09.
Well, if everybody was to shout the answer like this, you can imagine we will not finish. You know that. You know that. It will be very difficult to get the answer. So you raise your hand, I call you, but in this very question, I indicated that you should type your answer in there. So please, if you have the answer, you just type it. Shouting it into the air will not help much. Okay, so I see that the correct answer has rather been printed by those who typed there, which is 19.2. That's the right answer. 19.2. If you have been working it well with us, you will know that the median is 19. Now, the median is just one of the measures of central tendency, and that is not what I have to teach you. I just want to teach you how R brings out your results. The second thing I want you to work on, and please don't look at mine because mine, I'm hiding my answers. I want you to find the first quartile for horsepower. Find the first quartile for horsepower, and let me see. Type your answer for the first quartile for horsepower. Emmanuel Aijaba, Gabriel Cranch, Edward Jacob, Palena, Georgia J. Georgia J, you are wrong. Okay. Loretta, Evelyn, Roxanne, Francis. You guys are giving right answers. Theodora, Kingsley, Akute. All of you are giving the right answer. Okay. So the right answer is 96.5. So I can ask you to tell me anything in there. Okay. I can ask you. Who can give me the mean for kilosec? The mean for kilosec. What is the mean for kilosec? Parenda, that is a very good answer. Okay. Solomon, Kingsley, Akute, Philomena, Gabriel Cranche, Francis Tete, Edward Tete, Okay. Emmanuel Ite, Clement, Portia, Mensa, Obed, Penu, George Ajay, Noel Nuchiga, okay. Raphael Amponsa. All of you are giving you some incredible answers. Prince Techiba, Gilbert Mombasa. So all of those answers are good. So you should be able to generate statistics like that. However, the summary empty cards that I gave you guys is not enough. It does not give you enough of information. Rather, you need something we called describe empty cards. But before you can do that describe empty cards, you must install a package. And the name of the package is called Psych. Psych. So let me type it there. Library into brackets Psych. And this package, you must install it. I have installed it, so I can use it. Remember, these installations are once. Now, how do you know that you've installed it? Come to the packages on the right. Come to the packages on the right. And then click on packages on the right. And in the search on the far right, you type PS. And you see that Psych will be showing there. If Psych is showing, like mine is showing, which I am circulating it, it is an indication that it's already installed. And so you can take it, or you can run library Psych to invoke it. You can take it or run library Psych to invoke it. Once you are done with that, so you have to take it or run library. If you have not installed it, you have to click on packages, then click on install. A pop-up will come and you see install from repository, and then packages, separate multiple packages, space or comma. So under the packages, you type the name Psych. Okay, that's psychometric. As you start typing, you will see that it will show the PSYCH. And then you can now install it. After the installation, you should now see it in the thing when you type the name and the meaning. You see there. Once that is done, you run the package, you invoke it, and you type library Psych. And then now you can now describe your empty card. So you type describe into bracket empty cards. That's the name of the data. And then control enter or run. And at the bottom, you see some beautiful descriptive statistics. They are so beautiful. This is a descriptive statistics that you will notice there. So, looking at my descriptive statistics, which is similar to what you will have there, what is it that is in this one here that wasn't in the previous one? What is here that you can find, but it wasn't in the previous one, the summary empty cards? But the describe empty cards has given us a lot of information. Prince, what is it?
Trimmed mean.
Trend mean is 1.
Trim median. Trim median, yeah, I mean trim median.
Trend and median. What else? Emmanuel.
Skew and ketosis.
Skewness and ketosis. What else do you see? What else? Prince.
Standard error, the SE.
Standard error. What else do you see? Gabriel.
Range.
Range. So you can see that. Now, look at it from the range. The range, the skewness, the ketosis. Okay. All of these measure what? What do they measure, Prince?
Measure of displacement or dispersion.
So they measure the spread, the dispersion.
or variation. Yeah.
Okay. They measure how wide or close the data are. Okay. How wide or close the data are. And they are very important. So you need that in some situations. So you can now appreciate that describe gives us more information than that of the summary. So anytime you are trying to get, more information to select from, this is it. Who can tell me in most journal articles which four of the following are normally brought up a lot in a descriptive statistics in journal papers? Who can tell me 4 of these are fully brought up? Who can mention all the 4 for me without guessing? Grace.
Mean, standard deviation, the variance.
Oh, that's not correct. I think that you are trying to think. Okay. But that is not fully all of that. Gabriel Crunchy. Perinda.
It is the standard deviation, the mean, the minimum value, and the maximum value.
Perfect. You are clearly showing that you know what's about. So you if you don't know, and now that somebody has taught you, what do? You write them down. You write them down. One day you'll be grateful. Okay. So the ones that mostly people bring are the mean, the standard deviation, minimum, maximum. Okay. Minimum, maximum. Now there is one thing that is sometimes brought when you are dealing with non-parametric data. Okay, non-parametric data. Data where majority of the data sets are not normally distributed. Okay, they are not normally distributed. What 4 things can be brought here? That having been mentioned by the one the lady Grace actually mentioned. What other 4 things can be brought when you are dealing with non-parametric data sets? Who can guess? Non-parametric. Yes, Prince.
Let me try. So I think the skewness, ketosis, the range, and probably the true mean.
Okay, you missed the last one. Okay, the last one is
the standard error.
the
Okay, the median. All right. All right.
So for most non-parametric data, to indicate the disparity, you use the following: the range, the skewness, the ketosis, and the median. The median will be measuring the central tendency. Because guys, know that when we talk about average, the median is also an average. The median is an average. The mean is an average. The mode is an average. And so those things are actually brought in there. And then of course the rest will deal with the dispersion. So I want somebody to tell me the skewness for weight. Skewness for weight. Looking at your own. What is a skewness for weight? Not mine, yours. Because if you can tell me, then you know what you're doing. What is a skewness for weight? Let me call on someone. William Asamosu. What is a skewness for weight? Pauli.
I clicked on the package and it's still uploading.
All right, okay. That's why I deliberately called you. Teresa Bosomche. Teresa.
I think that my MP card is not downloading. It says error, so I can't
Okay,
even
don't worry.
see the output.
Let's go to Roxanne Minta.
Doc, that's 0.42.
Okay. Okay. So guys, you need to be able to know most of these things. Okay. You need to know most of the following things that your colleagues are mentioning. Now, there are certain things you can decide to do. We can decide that we want to know the mean for all the cylinders. See, so you want to get the groups. The cylinders are quite many. So you want to get all 3 cylinders groups and all 4 cylinder groups, and then be able to now be able to find their descriptive. So you are finding the descriptive statistics according to groups. Okay, according to groups. And most of the time, some of you will be doing that because sometimes your analysis requires that you analyze foreign banks, domestic banks, and state banks. And in the process of analyzing, you will need things like that. So I want us to do the following: attach empty cars, aggregate the data, add some fun, and then find the mean, and then other factors. Print out the result and let me see. Print out the result and let me see. So I'm going to give an example of this on my own, okay, so that at least on my own you can note and do it. You have to attach the data. I'm going to explain what I mean by attach the data. So you can see that here the data has been attached, because when you don't attach the data, you need to type a lot of dollar symbols to be able to let the person know that you are talking about this very data. Because what you don't know is that R is containing a lot of data. R has a lot of data. So if you want R to use a particular data, you want R to be able to use that particular data. Okay. So I've attached my data and I've generated an aggregate for it. And after generating, now the aggregate, like I said, is going to bring out all that we need to know regarding that very, very, information for cylinders that we are looking for. That is what we want to know. So you type what I'm typing, and then you find the variables that are inclusive in it. And you will see down there 4-cylinder car, 6-cylinder car, 8-cylinder car. They are MPGs, the mean MPGs, the mean for all of them, the displacement, the cylinder, okay, type, and all of that. You will get all of this in there. Let me see by hands those who have been able to get this. Let me see by hands those who have been able to get all of the median for each of the groups. Let me see by hands those who have been able to do that. Okay, so right now I have 2 people. Hey, the Fiaia, you are one of the people I think I said will get very good grade in this course. So I just pray that you are able to showcase your spiritual and psychological mind, okay, and make things work for us. Okay. All right. So only 2 people have done this. So I want you to do that and let me know. Only 2 people. 3 people now. I need to take some marks for this. Okay. 3 people now. Okay, let me give you a second to be able to do it. Let me give you a second to be able to do it, because you need to. Let me show you, see your faces, because I'm not monitoring you on your face. I'm rather monitoring you on my laptop, so I don't really see your faces much. So now I can see that there are people who are functioning. 5 people have been able to do it. Master, when ye be a yebio, now what the one will, okay, who ye be a yebi, because ube. Okay, so it's important. You see, back in school where people used to copy, now with COVID-19 you can't even get so. When you are going to his house, to go and copy, yourself, don't come. So yebi. Now how much would that them? Yebi. Na jai sha wo hwe yen pa no. Wo hwe yen pa so wo ble. Instead of you seeking support, raising your hand for support, no. Bla na wo bre. Emmanuel, have a question. Ask your question.
Yes, sir. So in my R studio, I've typed by equals list into brackets CYL. Like I'm getting the feedback CYL not found. I'm wondering what I could be doing wrong.
Did you type exactly as it is in the command?
So please, may I see your screen again?
Okay. Top left.
Just a minute, it's still loading, sir. Okay.
Check it.
Okay, sir. Thank you. I'll work on it.
I haven't gotten many people who have been able to crack this code. Empty cast is small letters all throughout. Small letters throughout. So always use the names and the variable description to guide. Only 7 people have been able to do it. Only 7. Only 7 people. Let me see now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people. Now the 10 of you have done it. I'm going to let one of you share his screen. And then show us your screen. If you haven't done it, I just put your hand down before I call you. Put your hand down, pay Mr. Put your hand down. Why wouldn't you say 1 year? Why wouldn't you? Okay. And our mouth so 1 year. Okay. So please put your hand down before I call you. The number has gone down by 1. It's gone down by 3 cry. Okay. 1 year.
Hello.
Yes, Gilbert, what?
Yeah, look, I wanted to suggest, if possible, that the text string can be pasted on the chat box.
Which text screen?
Because, yeah, like the script that we're supposed to type on the RStudio. Number 1, switching between the Zoom.
Don't worry, Masa. I know where you are going. Switching between what? See,
Sorry?
Let me tell you something. Do you know you have all of these things in the slide? You have them in the slide. Are you aware? I want to be sure you are aware first.
Sir, I have not seen this yet.
That is why you are asking the question. So please check the slides. Has the class rep Isa put this on the slides? Has he put it on the WhatsApp? Can you guys confirm?
Yes, please.
Has put it on the WhatsApp? Good.
Yes.
So if I were you, I'll print the slides and have it beside me. Whilst he's talking, I'm talking.
Okay.
Opele, do you get the point, eh? You see, you are
Yes.
doctor. You are an upcoming doctor. And as a doctor, people will not be doing things for you. You have to go and search and do things by yourself. And so if I have even guided you up to this step and given you the thing in your slides and you can't print up your slides, then the question is, how are you going to take responsibility to develop your own slides yourself? I have developed it for you. All right, so Dorcas Boateng, are you ready to share your screen? I'm giving you the opportunity to co-host and share your screen. Dorcas Boateng, you are now a co-host. Share your screen for us. Let me see what you've done. Dorcas Boateng, are you here?
Yes, please, I am.
Dorcas, please come again. And then share your screen. I am so impressed with the wonderful work you are doing. You have clearly been following the situation. And I can see clearly that your cylinders have been grouped according to cylinder 4, cylinder 5. This is what we normally talk about: V8, V4, V6, and things like that. Okay. Now, one of the things you can do, Dorcas, for us is that you can scroll the middle of your screen and then drag it to the right so that all of the groups are done in one. Go to the right a bit. No, not there, the right. Not going up, but going right. Going right. Hold that middle. Hold that middle. Let it turn to that diamond. Let it turn into the diamond. Slowly. Very good. Keep dragging it. Keep dragging it. Very good. That's okay. Excellent. So you guys can see the wonderful work she has actually executed. She's done some. So Doctor, let me ask you some questions based on what you've done. And by the way, all of them are showing the means. They are all showing the mean, nothing more. Okay. Now, I want you to tell me the mean displacement for a 6-cylinder car. The mean displacement for a 6-cylinder car.
That is 6. 183.3143.
Again.
183.3146. 43, sorry.
Very good. Very good. That's it. That's it. So what you've done is an indication that you can know what you're about. When I give you that assignment, that plenty assignment, you can execute it. Thank you. Okay, so I'm now taking the... Stop sharing your screen.
All right.
You are not going to detach now, but always remember that you will detach so that the MTCAS data will be taken from the print memory of the program. Now there is one more command that we want to do, and that is we are going to describe by cylinders. So you look at the word describe I'm going to use here. We are going to type this describe by cylinders. So that one is going to give us all the groups, and for each group, all the descriptives. Okay. So let me give you an example by here. Okay. We already have this command library psych, the library psych command. Okay. Library psych command. So, and we have invoked it already. So that's what we are going to use. So we're going to use describe.by mtcas. So this time we are going to get every statistic according to the groupings. So the statistics I've highlighted, each one of them according to the groupings. Okay. So we're going to do that. And that's it. I have just done mine and run it. So I'll give you an example. So when you look at the top one, remember there are 3 different cylinder cars. And the first one is the descriptive statistics for all the 4-cylinder cars. So the 4-cylinder cars combined, that is it. There are 11 of them. The N column is showing that there are 11. Then you have their mean MPG, their mean cylinder, their mean displacement, their mean weight, and all of that. Their standard deviation, the standard deviation, that standard deviation, and so you have the descriptive statistics for all the 4-cylinder cars, all the 6-cylinder cars, and finally all the 8-cylinder cars. Descriptive statistics for all of them like this is very good, because sometimes you can't go and get it for all of them and do it for this group and do it. I can do all of them at the same time for you and group them as well. Okay. We once wrote a paper where we did a lot of contingency tables in formats like this. Okay. But then, so in this case, when you want the mean, the standard deviation, the minimum and the maximum, you can easily extract from here and then be able to represent them for thesis. Okay. Now, I want to see by hands all those who have been able to do this that I just did. Okay. Right now, so many people have raised their hands, so I don't know whether. Okay. So please, if you have raised your hand and you have not done this, lower it. I want to see all those, because I'm going to let 2 of you share your screen again. I'm going to let all those who have been able to do this to raise their hands. Okay. Akute, have you been able to do it?
Yes.
Okay, all right. So I'm going to allow you to share your screen.
Unfortunately,
you said you need to do it, and there is unfortunately.
Unfortunately, I'm using 2 screens, so one is a laptop and the other is a screen, because the camera on my phone is not working.
All right, okay.
On my laptop, it's not working.
Okay. Solomon, can you share? Solomon, can you share?
Yes, Doc.
Okay. So let's see whether Solo will be able to share his screen. Whether Solo, I need to make you a co-host, which I've done. So please kindly tell us what you have. Take over and share with us what you have. Everything is in the slides.
I'll do this what I have.
Good. He has everything nicely organized, nicely packaged. So guys, this is just to let you know that while someone might say that I'm just lost, I am lost, I don't know where I am, I'm in a Hebrew land. Okay. While someone is saying that, somebody too is flyingly enjoying the procedure. And that's what you want to take note. Now the most important one, so I want to share my screen for you. Ladies and gentlemen, you can check if your data is normally distributed. If your data is normally distributed. Please, can somebody tell me, why do you think you need to check whether your data is normally distributed? Who can give me an idea? Why do you think you need to check if your data is normally distributed? Anybody? Anybody? Why do you think, what is normally distribution? Loretta, go ahead. Yes, Loretta. Why do you think so? Raphael?
Yeah, sir. So we check that our data is distributed to be able to see the outliers.
Okay.
So we can deal with them.
All right. So one, you want to see the outliers. What else? What else apart from seeing that? Akute. Akute.
Hello, Prof. I'm not too sure.
Okay. Your hand was up. So, ladies and gentlemen.
Sorry.
Hands are being raised again. Okay. Eric, hear me.
Sir,
It helps determine if your sample is normally distributed. If you selected your sampling correctly.
Yeah, why are you doing that? That's my question.
Because that has an implication on how you generalize your findings.
Why?
um, yeah,
Please mute yourself. Why? Okay, Cynthia.
To see how the data is related, how related the data is.
Cynthia, would you want your data to be normally distributed?
Yes, but
Why?
so that will tell you how they are, related or not.
No, hold on. I asked you, would you want your data to be normally distributed? Would you want?
Yes, please.
Why?
Because it will help me know how widely spread or how
Then you wouldn't want your
closely
data
they
to be
are.
normally distributed. Then you would want your data to be widespread. My question is, why would you want your data? Why would you want to be a woman? You say, I would want to be a woman because I don't like to be a man. No. But why would you want to be a woman? Why would you want your data to be normally distributed? If you had told me you don't know,
So that it will help me in the conclusion.
no, it won't help you in the conclusion. You got to know why you want your data to be normally distributed, first of all, before it will help you.
Doc,
Saying that data that are not normally distributed, they don't help in conclusion.
hello, Doc. Doc, I want to attempt something.
Hold on. I know your hand is up. Yes, Gilbert.
Yes, Doc. The normal distribution is most natural situation.
Again,
Data take. Yeah, I'm saying that in most natural situations, data takes a form, what you call the bell shape. So if you take, for example, salaries paid within a company, you have the lower band, you have the middle band, and then you have the upper band. Mostly the lower and the upper bands are minimal. You have the middle band taking majority of.
I didn't say explain normal distribution for me, which is what you are trying to do. It's fantastic, but that's not my question. Why would you? Okay, unless I ask you the question, would you want your data to be normally distributed?
Definitely.
Hey, you have added definitely. Why?
The reason is if you want the data to be reliable, you ensure that it is
Why would you
normally
want the data to be reliable? Who says that when data is normally distributed, it is reliable? Is that what you are saying?
what it means is that all the other parameters will fall in place.
Well, what?
I'm saying that all the other parameters will fall in place. For example, if you have data that is not normally distributed, and you take the median, for example, it might fall outside of place, okay, or even the standard deviation, simply because your data, all the parameters associated with that data are correct.
All right, okay. You've tried. Let's go to Raphael.
so, sir, as I was saying earlier on, it's part of more or less explaining the data, helping us to understand the nature of the data, and also to make sure that the data actually gives or conforms to natural phenomena.
Oh, I've lost him again. All right, finally, David Akpali.
Okay, it's exactly, yes. Doc, if you know the nature of your data, it will help you in the analysis. For example, if the data is normally distributed, you may want to use the mean. But if there are outliers in the data, you may consider median. So to help you with a more accurate analysis of your data, it's important for you to actually ascertain the nature of the data, whether it's normally distributed or there are outliers in the data.
You have spoken well, but you've generalized it. You didn't specify it. Okay. My question was, would you want your data to be normally distributed? Yes or no?
Yes, please.
Why?
Because it makes analysis simpler if you
Good.
have
It's okay. That's all
a
I
normal.
want. That's all I want. It makes analysis easier. And the reason why it makes analysis easier is because many things in life are already normally distributed. Many things in life are already normally distributed. And so if the data is normally distributed, it just conforms to what is already the natural situation in life. And that is why it makes analysis easier. It makes analysis easier. Now, it doesn't mean that many data are not normally distributed. Okay, are all normally distributed. Some data are not normally distributed. Some are binomially distributed. Some are Poisson distributed. Some are Weibull distributed. Some are gamma distributed. Some are half normally distributed. Some are truncated normally distributed. Some are censored data. And in situations like that, you would want to even normalize them. Sometimes we try to log linearize data in order to normalize the data. So sometimes if you check some statistics and research analysis, the author will use a log of the dependent variable instead of the dependent variable itself. Okay. So that the person will be able to normalize the data because it's easier. It conforms to the natural sentence. Okay. So that is it. So one of the first things you want to do with any data you have is to check normality of the data. And so what we are going to do is that we have so many variables. Okay, if you can remember, there's MPG, there is cylinder, there is draft weight, automatic, manual, vertical, speed, displacement, and all of that in this data set. We want to check if some of these variables are normally distributed. And how do you check? It's a very simple thing. Okay, one way you do is that there are several test statistics you can use. Okay. The p-value and the alpha are compared, and whenever they are compared, you can use that to dismiss normality or retain normality. And one of the things you will notice is this, that whenever the p-value is greater than the alpha, then the data is normally distributed. But what do we mean by the p-value? And what do we mean by the alpha? Alpha is the level of significance. I'm telling you things that you have to learn on your own. Okay, alpha is a level of significance. Alpha is the expected situation. And we have three main different alpha: 1%, 5%, 10%. Now let me give you a better understanding of alpha. So alpha is a certain benchmark criterion which has been set. For example, the minimum wage has been set in almost every country. And so the moment you are above the minimum wage, you are considered something. And the moment you are below the minimum wage, you are considered. So the minimum wage becomes a benchmark. A benchmark. Now, alpha is like that. Alpha is the expected mistake you are likely to make in any research. I want to repeat that. Alpha is the expected error that any research person may encounter. So let me give you an example. Let's say that you make a statement that NDC won the election. NDC won the election and that the electoral commission was really, really bad. NDC won the election. Now, if you make such a statement that NDC won the election, you have to justify it. Now, in the process of justifying that, you will have to gather information, gather data, and all of that. Along the line, you will make some mistakes. Now, what you don't know is that there is some expected mistake you are supposed to make. The mistake you are expected to make is known as the alpha, the level of significance. The mistake you are expected to make, the mistake that you are allowed to commit in your process, the error you are allowed to make is the alpha. But then beyond that, you are not expected to make more than that mistake. The mistake you actually make is different from the mistake you are expected to make. Accountants will understand you better. That the mistake you actually make in this context is known as a p-value. So the p-value is the actual error. The alpha is the expected error. You want to take note of this because you will need it in your descriptive situation sometime to come. So, which one would you want it to be bigger? Well, to be honest, actual mistake, you want that to be bigger. You want the actual mistake to be smaller and the expected mistake to be bigger. So the mistake you actually make is like that. But in hypothesis testing, in normality testing, the p-value is expected to be bigger for the data to be normal. So we're going to pick one variable, and I want us to pick the variable known as MPG. So look at the variables here. MPG, the miles per gallon. And what we are going to do now is that we're going to check whether that data is normally distributed. To do that, let's go. We have to use one of these test statistics. These are some of the tests. You can use the KS normality test, Shapiro test, Jacobera test, or Dago test. Okay, all of this, D'Agostino test, and all of those Jacobera test, Shapiro work test, Komogorov-Menos test, all of these tests, there are quite a number of them. I am going to use the Shapiro test, the Shapiro works test for normality. So, in order to do that, I am going to load a package. Let me see the package I would want to load. I'm going to load a package called Shapiro Test. There are two of them actually. One is Shapiro.test and one is Shapiro Test. Okay, so ladies and gentlemen, you are going to type with me Shapiro.test. Okay, and Shapiro Test. We have already attached the data, so I'm going to show you how I'm doing mine. So watch me as I'm doing. Look at it.
The video. Okay, video.
And then look at the top. I have typed Shapiro.test. The one I'm actually going to work on is this. So I'm just going to show you. So you are going to work on this. Shapiro.test. But you will not type $MPG because we have already attached the MPG to the memory of R. So it's just going to be Shapiro.test into bracket MPG. That's all. Do that, run it, and tell me the p-value. Do that, run it, and tell me the p-value. If you have the p-value, raise your hand. Do that, run it, tell me the p-value. If you have the p-value, raise your hand. Do that, run it, and tell me. A parenda.
Yes, please. The p-value is 0.1229.
How many percent is that?
That's 12.29%.
Okay. Is that bigger than the alpha? By the way, alpha is always 5% default. Is that bigger than
Okay,
alpha?
yes. Yes, please.
It's bigger.
Yes, please.
Okay. So since that is bigger than alpha, what do you think will be your conclusion? Is the data normal or is not normally distributed?
Okay. Since the null hypothesis is saying that the data is normally distributed and the p-value is bigger, we are concluding that the data is not normally distributed.
So what is your conclusion?
The data is not normally distributed.
Okay. Prince, what is your conclusion? Prince Techi, what's your conclusion?
I think I disagree because if you look at the alpha value is 5%, the p value is 12.29%. Yeah, the p value is greater than the alpha value, which is 5%. So therefore, the data is normally distributed.
Exactly. The data is normally distributed. The data is normally distributed. If you have been going through the lecture. So some people will get it. There's no question about that. Some will get it as we go through this process. Some will get it. Okay. But like I always say, when you lose focus slightly, you might realize that, yes, like somebody says, I'm lost. Somebody just type in there, I'm lost. Now, if you are lost and you just type in, I'm lost, that's the one you haven't done anything. Because you saying I'm lost, somebody can say, I am found. Okay. So I'm lost is nothing. I'm lost is just a way of expressing your sentiment. Okay. So the data is normally distributed. Now, I haven't done this, but I want you all to do this for me. Can you all now check for me whether the displacement is normally distributed or is not normally distributed? All of you should do that. Let me see those who can. Emmanuel, you have a question?
Yes, sir. I have a question.
Yes.
Yes, sir. But it seems like you have already answered. I was going to ask that is there a criteria for selecting the variable with which you check for the normal distribution?
Okay. And
Yes, sir.
you have already answered you, so that's fine.
Yes, sir.
All right. Okay, some hands are up. Roxanne, what do you have?
Please, I didn't hear the command you asked us to type.
I said check whether displacement is normally distributed or not. If you go to your data, you know one of them is displacement. And the way it was written in the data set was DISP. So check whether it's normally distributed or not. If you were able to follow how we did the MPG, you can use the same approach.
All right, Doc. All right, Doc.
So who has been able to do that? Raise your hand. So many people have raised their hand, and yet I don't know whether they've been. Grace, what is your answer?
0.0208.
0.
0.0208.
So is it normally distributed or not?
It is not. It's not.
Are you sure? The way you said
Yes, I was calculating.
So is it or it's not? Is it or is not?
It is not, please.
All right, okay, that's correct. Okay, so displacement is not normally distributed. So you guys can see that MPG is normally distributed, and yet displacement is not normally distributed. Now, can you check whether Q-sec is normally distributed? Can you check? You see, what I'm doing is I'm helping you, I'm giving you confidence in how to test for normality. Because you will test for a lot of normality. Check whether Q-sec is normally distributed. And when you are done, Loretta, is your hand up? Check if Q-sec. Solomon, tell us. Solomon Odeapia.
Yes, Doc.
Your hand is up. It means you are ready to answer.
Yes, Doc. The p-value is 0.5935, and so I can conclude that the data is normally distributed.
Exactly. Q-sec is normally distributed. Some people are on top of the game. Others are on top of the game. Okay. So Q-sec is normally distributed. Okay, so you can please all lower your hands now. So, ladies and gentlemen, we've been able to test for normality. And now, anytime you have any data, you should be able to test for the normality of the data. When we come to the world of regression, you will learn how to test for the normality of the errors in the regression. Now, let's continue. Let's continue. Another way of checking for normality using graphs. See, sometimes you might not need a test. Sometimes you might use the graph. And one graph you might use is known as a normal quantile probability plot. You have it on your screen. It is where you have a QQ line and a QQ normality plot. So you can scatter plot the data, and then you also draw the line. All you want is that the dots will be sitting beautifully on the line. If the majority of the dots are sitting nicely on the line, it means the data is normally distributed. Okay, if majority of the data are sitting beautifully around the fitted line, then the data is said to be normally distributed. Now, we have already confirmed that MPG is normally distributed, and you can see the majority of the MPV data are sitting around the fitted line. Okay, so I'm not going to use that. So I want you now to use another variable, and the variable I want you to just using the variable and checking. Okay, so I want you to use the variable which is known as horsepower, HP, small letters, horsepower. Okay, and then check using graph, quantile normal probability plot. How do you do that? All you have to do is to type QQ norm into bracket HP, then semicolon, QQ line into bracket HP. Okay, so you just use that HP and then run it with the HP and then tell us whether it is normally distributed or not. The graph will tell you. The graph will tell you the situation. I have done mine. I hope you have done yours. I've done mine. You wouldn't see mine. And I can see the way mine is. And I'm now checking carefully whether it's normal. Just looking at the graph, what would you say? Would you say it's normally distributed or Gabriel Crunchy?
The most of the dots sit on the line, so I think I'll say it is normally distributed.
You are sure of that, eh?
Not so sure, but most of the dots are either on the line or very close to the line.
Good.
That's why I want to say normally distributed.
You're not that sure, isn't it?
Yeah, yeah.
Okay. Do you know what would have made you sure?
I should have run the Shapiro test on that one.
Yes, that would have, but at least I didn't tell you to do that, so no problem. Okay. But let's go to the rest and see. Yes, Loretta. Loretta. You're raising your hands, and anytime I call you, don't respond.
Like said, I think it's normally distributed. Then so both of them are
It's not clear, but what I see, I think it's normally distributed.
All right, okay. Okay, so finally on this, let me ask Roxanne, what do you say?
Doc, my graph here, I would say it's not normally distributed.
Okay. So it is normally distributed. And I agree with you. Graphs don't tell us enough. Graphs don't tell us enough. So one of you can go and run the QSEC and you'll see that it is 0.048. Almost 4.8%. And that shows that it's not normally distributed. Oh, did I say it's normally distributed? Okay. So that shows that it's not normally distributed. So I can understand those who say, because it's so close, it's not that obvious. But the Shapiro test will tell you clearly that it's not normally distributed because it's below 5% p-value. So what does this tell you? What this tells you is that it's not all the time a graph will give you the answer. Sometimes you don't need a graph. Sometimes what you need is both the graph and then the test. The graph and then the test statistic. And that will guide you. Now let me show you empirical work, published papers in journals. Okay, that tells you clearly how these things are done. So this is a paper from Margaritis and Silica. It was published in the Journal of Banking and Finance. And this is a very good paper. The data was made up of French firms in 3 industries. The industries are chemicals, computers, R&D, and textiles from 2002 to 5. Okay. And they wanted to look more at the impact of previous dynamic data and handle identification and endogeneity. All of these things you learn. The data was taken from a certain group of banks. So this was the data. Watch carefully. My interest is for you to watch carefully the way he has organized the data. He has given the mean, the standard deviation, and the median for each industry. For each industry. For each industry. And then at the bottom of the page, he has indicated the concentration by ownership. So these are some of the ways that you can check how people present their data. Okay. Now the details of the data and speaking about that data and everything there, I have written it here for you to check it later on your own. The panel B, how it also explains the data. I've checked it nicely for you. But one of the key things you want to note is this. Whenever you are talking about your data and you are mentioning certain results, you want to juxtapose that with what other authors have done in the literature. That will help you. All right. The next thing that I would want us to look at are graphs. Why we need graphs to do our quantitative work. Okay. Why we need graphs. Because graphs are very, very important. Okay. Now, the advantages of graphs before we go there. Okay.
Please have a question.
Yes, Roxanne.
Hello, Doc. Yeah, taking you back to the horsepower using the Shapiro test where we had 0.04881.
Yes.
What is the application of you running the last value because it's more, it's making it 0.05?
Ask your question again.
Yeah, Doc, where we did the Shapiro test for the horsepower and has 0.04881. What's the statistical implication of a researcher running it up to 0.05?
If you run it to that level, okay, you will conclude as if it is above it. All right, you conclude as if it is above the 5%. So if you run it and it is 0.05, you're going to conclude as if it is above 0.05. And if it is above 0.05, we know that it's normally distributed. And so if you don't want to, if you want to push it to that level, you can say that. If you don't want to push it to that level, you can also say that. See, when you're in the middle where you can choose any line, at this stage, you can choose any situation that best suits you. Maybe you wish the thing is not normally distributed to make a point you want to make. Then in that case, you round it to prove your point. You get it?
Okay.
But if
Thank you, Doc.
you want to be normally distributed, then you leave it as it is and you conclude that it's not normally distributed.
Okay. Thank you.
All right, Gabriel, you have a point. Gabriel.
No, sir, please. I don't have a question.
Okay, Gabriel. All right, so that is how you got to be. Graphs are quick. They highlight the most important fact. They can convince the reader, and they can be easily remembered. That's graphs. So graphs are very, very important, and it is very important to understand graphing in such research. Now, there are several graphs: scatter plots, line plots, histograms, smooth plots, dot plot, contour plot, image, 3D surface, 3D scatter, conditional plot, parallel coordinate, star plot, stem and leaf plot, okay, fourfold plot, mosaic plot, and so many of them. Here's Cynthia. Cynthia, your hand is up. Cynthia, your hand is up.
Yes, Doc. Please, I'm very sorry, but I'm a bit confused. When we did the graph, for mine, I saw that if I were to draw a line, lots of the dots would be on the line. So I would generally conclude that it was normal. But the answer you gave, you said it was not normal. So that's where my confusion.
My dear, you shouldn't be confused because I indicated that this one was too close to call. So the best is to use the Shapiro Test.
Okay.
That is why I said that if your eye is different from my eye, but numbers no lie. You know that.
Yes.
So you have to use the Shapiro work. It doesn't mean that because it's a graph, every time we use a graph. When there is that kind of clear confusion, you just use a test statistic because I will tell you exactly. As for the graph, somebody will say that I see 12, which are on the line. Another says, I see 10 are on the line, but 12 are not on the line. Someone says, I see 12. What if the data is 2 million? Are you going to count all the 2 million? So it's not that clear when we use graphing. When we use graphing and it's clear. But when it's not clear,
thank you, sir,
we use the other ones. All right. So let's go to the graphings. Okay. So there are several of these graphs, but you don't need all of them. Sometimes you need the ones that are necessary. Cynthia, is your hand up again? All right. You don't need the ones that are necessary. You only need the ones that you need. So there are several of these graphs. These are some of the plot symbols we'll be doing. Okay. Box, where you use a box to represent, or a triangle to represent, or box to represent, or diamond box, triangular box, and so many of these symbols, the plot symbols. That's what you use a lot in R. You're using that. Then CX is the size of the text symbol, the size. So CS4 is smaller than CS8. CS8 will make the size of the text very big. Okay. Then POS will deal with the position of the text. So if you have drawn something and you want the text you write, like fortress, you want the fortress to be on top of the line, below the line, on the left of the line, on the right of the line. The numbers you indicate will indicate where they are supposed to be. This is a programming language software. And then there are other things that you can deal with. LT is important for me because it talks about the type of line. You can change the lines. Some of them are zigzag, some of them are straight lines, some of them are double zigzag and things. LWD is a line width. The default is 1. If you want the width of the line to be tiny, use 1. If you don't want that, you will use something like 4. Okay, 2 is twice as the wide. And so these are some of the line types. You can see there are several of them. You see all of this in textbooks. And some of them are dot, 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 some of them are dot, 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 some of them are and so many things. And then the colors, you can apply 675 colors, 657 different colors. Okay, these are some of the colors. You can use several colors in your plots. And each color has a name. Each color has a name. So if you use a color like, 461, it will indicate the name of what you want to deal with. So color is important. Sometimes you write the actual name of the color. If you say red is red, but if you look at it carefully, there are some that are red and some that are different color names. I'm telling you, R has more colors. So I want us to do 2 of these before we wrap up today, because you will use all of these things you are learning in your assignment. So go back to the MT-CAS data, and I want us to plot the weight against the MPG. Now, this is what I want to do. I want to know the relationship between the weight of the car and the miles per gallon of the car. It's a scatter plot I want to do. And this is it. It's a scatter plot. What I want to do is I want you to plot the 2 for me using this command and running it. The color should be blue. The line weight is 2. The position should be 24. The color label is red. And the title is written as plot of MPG on weight. Do that and let me see. I want about 2 people to share their screen when they are done. Plot this nicely and let me see. Plot it nicely and let me see. It's not for okay. Perinda, let me just give you a co-host and then show your screen and let me see. Perinda, show your screen and let's see what you have. Perinda, click screen share. Okay, so that's what she has beautifully there. She has it so beautiful. You see, when people are so prepared for this course, they do everything so nicely. She's even expanding it for you guys to see it well. The y-axis is showing the miles per gallon. The x-axis is showing the weight. Now, looking at the relationship between the miles per gallon and the weight, what would you say? Is the relationship positive or negative? Perinda, you yourself, since you are the one in charge, is this showing positive or negative relationship between miles per gallon and weight?
Okay. Doc, please, it's difficult to tell.
Oh, have you eaten? If you have eaten, it's not difficult to tell at all. Okay, so let's see whether somebody can help you. Edward, can you help him? Can you help her?
Yeah, Doc. I think it's negative.
It's negative. Why do you say that?
Because if you look at the way they are distributed, you realize that it is more of the inside from the top of the y-axis to the right of the x-axis. Especially when it is the trend is like that, it's negative. If it is the opposite, from the 0 to the top is positive.
Exactly. You're right. You're very right. This one, nobody can beat you against it. You have set the nail on the head. Okay. Because when you look at it carefully, when you look at it very carefully, it appears as negative, because you see that majority of the data are from the top coming down, but they are moving towards the right. They are coming down all right, but they are moving towards the right. And so that shows a negative relationship. Now, what does that mean? It appears that makes practical sense. Why do we say so? because you will know that if a car's weight is very, very high, what it means is that the MPG of the car is very, very low. That's what it means. And we know that that is the case. Okay, the miles per gallon of the car is usually low when the car is getting bigger and bigger and bigger. Fantastic. So thank you very much, Parenda, for showing us your screen in that situation. Now let's go on to another graph. Okay. Oh, and by the way, this graph that we have just done, you can change some things. You can change certain things in that regard. Let me just show you what I mean. If you look at this second one, you can use histogram. So you can use histogram on the same MPG. So I want you to do this command. And don't use my red. You see, I have red here. Don't use red. Use another color. Okay, so I want you to have a histogram here, and it should have 10 bricks. The x-axis should be called miles per gallon. The color should be blue. The color should be blue. The main histogram, the title should be histogram of miles per gallon. And then the color main should be green. Okay. So what I want you to do now is to change some of them. You know, when I've used red, use blue. When I've used blue, use green. When I use turquoise blue, turquoise green, you know, blue, blue. You know, the women are very, very good at colors. Periwinkle, purple, you know, orange. So just change some colors and then plot the histogram of the MPG. We want to see how the MPG is, you know, distributed in terms of the histogram. And if it is well distributed, you see that it's normally distributed. So let's see. Let's plot it and see. When you're done, once again, show me, raise your hand, and then you can share yours with us. Who is that? Oh, I think all of you are done. Clement Mensa Damwa, are you done?
Yes, Doc, I'm done.
Okay, so Clement, what I'm going to do with you is that I'm going to let you show, I've given you a co-host so that you can share your screen with us. So share your screen with us and let's see. Share your screen with us so that we'll see.
No, I don't.
Yeah, the Shapiro work was 12 point something percent. So it goes to show that, you know, there appears to be some normality. That's what it says. So it shows that there is some form of normality in that regard. Okay. So that is another way of demonstrating the whole issue regarding the plotting. Now let's go to the next one. Okay. And probably that will be the last one. Okay. It's known as kernel density plots. Kernel density plots. And it is now becoming the order of the day. Anytime you're going to use histogram, it's advised that depending on the analysis, you should rather use kernel density plot, especially when you have a highly non-normally distributed data sets which are highly skewed. Kernel density plot is a statistically sound method, okay, for estimating continuous variables. It is more or less a replacement of the histogram. And so, if you want some more information on kernel density, I've given you some link for you to go and check it. And some papers that have used it, which in a very nice way I love so much, these papers are down here. Okay. One of them was on the conditional stochastic kernel estimation of non-parametric. It's a beautiful, beautiful paper that shows beautiful graphs of kernel density. Okay. So, we are going to draw the kernel density graph for the MPG. And we are going to use this command. Please, I want you to do that. I don't want anybody to use color blue. And I want to see those who will be able to do that and show me. Show me your kernel density graph. Don't use color blue. Don't use color blue. And then once you are done and your hand is up, I will let you show me the situation. Once your hand is up, I'll let you show us your screen. Who has been able to draw the kernel density for MPG? Emmanuel Jaba. Emmanuel, are you done?
Yes, sir, I am.
Okay, so share your screen with us. You have the chance to share your screen with us. So at the bottom, click share screen and then share your screen with us.
I don't have that option yet. I think you have to make me go. Okay.
You don't have?
Okay, yes, I've seen it.
Okay. So we are all patiently waiting for you.
Please, can you see my screen?
Exactly. This is what we sometimes refer to as the bell shaped. So, Iman, when you look at it, does it look like it has a bell shaped?
Yes, sir, it does.
Iman, which
Because
color did you
majority of
use?
the gray. I use gray.
Oh, okay. So it appears
It has a bell.
it shows up more or less like it's a bell shape. And again,
Yes.
the Shapiro Test is guiding you. Can somebody change his own from MPG to horsepower and plot it for us to see? Can somebody go and change MPG and use HP and plot the kernel density graph for us to see? In fact, if you are done, because so many hands are already up, if you are done, you have to just make a bit of a noise for me to be sure that you are done. Then I'll let you show us. Gabriel Crunchy. Where's Gabriel Crunchy? Okay, Gabriel. I'm just giving you the chance to show us yours. Okay. So show us yours, Gabriel. Take up the screen and then show us your own that you have. Okay. So Gabriel, looking at the beautiful kernel density, and I see that you've given it a very nice name there. Now you have the bandwidth and you have the distribution. Now guys, I'll tell you about the bandwidth, but Gabriel, does it look like it's normally distributed?
Not really. It looks like it is more skewed towards the right.
Towards
The right.
okay.
Sorry, the left. The left.
All right, okay. So if you look at it carefully, there was something called the bandwidth. The bandwidth. Guys, the bandwidth tells you the bit rate that is consuming the data communication. Okay. And it's usually expressed in bits per second. It is that free parameter which shows a strong influence on the estimate. So most of the time you do bandwidth, there's a lot of history about bandwidth. I don't want to bore you about it. You collapse. Okay. But there's a lot of history about bandwidth that you have to know. Okay. And bandwidth, sometimes you allow it to spread. You see, the bandwidth can let the thing go flatter or steeper, okay, depending on how you increase it. So the default bandwidth is what is working behind the scene. But if you want to change the bandwidth, you can always remodel the thing and then change the bandwidth. All right. So all of these are just to help you to know some of the graphical analysis in there. Now, ladies and gentlemen, that is not all the graphs. Next time, we are going to do a couple of graphs. Okay. We are going to do some graphs that you can put them together. You can stack the kernel densities together like this. Okay, where you have multiple graphs, because sometimes some of you will be dealing with groups. And when you have groups, you need to be able to know how to deal with these things. Okay. So we'll come and learn how to draw according to groups. Then we will also learn how to do bar charts according to groups. We will learn how to stack some bar charts on some others according to binary analysis. For example, vertical speed. And then we will look at more bar charts that are geared towards double, not vertical, but straight horizontal interpretation. We will look more at lines. We will look more at lines according to across groups. And then we'll look at how you can put all 4 or 5 diagrams on one page. You can command R to do that. And then we'll look at box plots. Box plots is a very, very interesting area to look at. And then bar plots. Because some of you will need these things. Some of you, when you start using them in your thesis, Okay, people begin to appreciate it a lot. I'm telling you. And then we'll look at scatter plot matrices in different ways. And now, final ones. These are the interesting areas, those in finance and those in operations and all of that. We'll look at 3D plots and how beautiful they can showcase certain things. Okay. We'll look at 3D plots with the surface lines. And then the scatter plots are actually in the middle of it. Okay. And how these things can actually showcase the beauty of things. And then finally, you can see boxes that move. And the things are inside them. And finally, we'll look at how to name some countries with boxes and identify some legends in them. And surface graphs. And finally, your world map. We'll find out with them. And then I'll tell you your first assignment. Ladies and gentlemen, that